everyone. Thanks for coming here. It is my honor to be here to share with you what we're building at PredictionIO, and at the same time, give you a brief background idea why we're building PredictionIO, why we think it is so important to empower developers to have access to machine learning technologies to build smarter applications. Again, my name is Simon. So if you look at the history, it is not difficult to realize that human life has been improved dramatically by technological advancement. From Stone Age to the future life that we are envisioning right now, flying cars everywhere, robots walking on the streets. And throughout this improvement, throughout these changes, we can see that a lot of them are empowered by developers. Developers make scientific achievement or theoretical ideas into practice. They put that into application to make the world a better place to live. So I think Hollywood has done a great job to tell us what we can look for in the future. But what's next, really? Today we know that machine learning is really powerful, especially when it meets with big data. But back some years ago, a hospital in Tokyo, they already deployed a robot, receptionist robot. So if you're going to hospital and visit the patients, the robot can show you the right room where you should be. Or in medical research, we can now predict patients to respond to cancer treatment. And also in cities, like cities in Germany, they can now predict traffic up to 30 minutes in advance with a 90% accuracy. And think about the police department. They can predict the next crime, where it will happen. And globally, like in UK, also the Ministry of Justice, they're already relying on big data to make decisions to determine or to predict the likelihood prisoners will reoffend. And in the education industry or education field, educators are trying to use big data and machine learning to help the next generation to pick the majors. Are you a good engineer or not? Well, it is kind of controversial, but this kind of things are happening right now. And we all hate ads, or we don't. Depends if it is personal enough, if it is relevant enough for you. But imagine if all ads are relevant to you, useful to you. You're basically like looking at a magazine or news when there's an advertisement displayed in front of you. So this field is called machine learning, a field of study that gives computer the ability to learn without being explicitly programmed. And it has been described really, really long time ago. But not every computer can learn. And so we're differentiating computers that can learn from those that cannot. And machine learning, the whole idea is really about computers learning to predict from data. I think this pyramid is really important. It describes how we're using data in the past century up to now. In the past, we're really happy that we can store information, we can store data. We're glad that we have database. It's a great invention. And later on, we need more power to search the information, to look for things that we have stored. And then we try to get meaningful insights from the data. So we want to see what has happened. And then we need information. We want to see what's the meaning behind the information of the data. But now we're really moving up to the top of the pyramid. We want to make better decisions based on the data that you have. No matter what kind of applications you're building, it is important. So we're climbing really hard up to the top of the pyramid right now. And machine learning and big data movement is helping us to get there. So the two common prediction tasks is regression and classification, technically speaking. So regression, it sounds confusing, but the idea is really simple. Regression just means that you have an input and you go through a black box, you call it prediction model or something like that, and then it will come up with a prediction result. And the result is in real value. So you're predicting the exact temperature value it is called regression. But if you're predicting whether it rains or not tomorrow, so it's kind of like you want to classify the weather tomorrow, and that's called classification. So in the algorithm side, they make a huge difference. But when we're trying to understand it from the application point of view, they're really just about real data, real value, or class that we need to classify the prediction into. So let's look at this really simple model. If you have an object and you input it into any kind of predictive model that is built based on any kind of algorithms you can find, like Mahout, GraphLab, Spark, they have machine learning libraries now. Python, they have scikit-learn. So there are a lot of machine learning libraries that you can use to build this kind of predictive model. And through this model, you can get a prediction output. Depends on what applications you're building. But what I find really, really interesting is this model. How about we want to predict the correlation, the relationship between a user and an item? The item can be anything. So what we can do right now is we can predict user preferences, or we can predict user behavior towards an item. So am I going to buy this product? Am I going to sign up to your website? Am I going to win this competition? So this kind of relationship behavior is really interesting in prediction to me. And so really, PredictionIO right now is focusing on this kind of two items, user and item relationship prediction. By predicting user preferences, you can do a lot of amazing stuff. You have heard of Coursera, right? Coursera, you can take machine learning courses, you can take a lot of different other courses online. And they have a huge database of courses that you can choose from. So after I've taken this introduction to machine learning, which course I'm going to take next, it would be great if they can recommend me some relevant course or the course that I want to take next, right? I don't think they're doing it really good at this moment, but they can if they put more resources on machine learning. Smarter Uber, you can call a cab with your mobile application. So now the ranking of drivers is really just based on location and price. But how about I care more about the cleanness of the car, I care more about the model of the car, things like that. Everyone has different preferences. So by putting machine learning into the application, you can re-rank the driver list based on user preferences. And App Store, we want to help users to discover apps smarter. Or food delivery applications, you want people to recommend, or application want to recommend users the meal that they want to order every day, which solve a big problem for me at least. So you can make everything smarter just by the previous simple diagram, predicting user and item preferences. And it sounds like magic to some people about machine learning. Well, how can we predict the future? Based on the data, what we can know is existing thing, right? What has happened already, we can know it for sure if we have data. But how can we predict the future? There are a lot of research disciplines focusing on predicting the future, and especially for user behavior prediction, there are two main streams. One is called content-based recommendation or content-based prediction. The other one is called collaborative filtering. People like to make really hard terms. What's collaborative filtering? I don't know what it is when I look at it. But really, it's just about using your previous behavioral data. It's using other users' behavioral data. That's it. So in content-based recommendation, let's say if we're building a news recommendation engine, if I want to do a content-based recommendation, I would need to analyze the news article, maybe extract some key points in the article, and then we will record what news you're interested in, and then I will build a profile about you, what keywords you like. It's just an example. And then later on, when the new news come up, I can use this predictive model to predict whether you're interested in this news or not. So that is called content-based recommendation. Collaborative filtering is very different. Let me use some time to go through the details a little bit briefly. So if you look at this matrix, you can see that there are 10 users and 5 items. Items can be news, can be application, can be courses, can be anything that you want to predict. So in this matrix, you see some values in it. The values can represent user preferences. Let's say if it is like Amazon or Yahoo, you can give a 5-star rating. 5 means you like it the most. 1 means you don't like it. So in this case, you can see that user 1 give a 3 rating to item 1. And user 4 give a 5 rating to item 1, and so on. Okay? So that's the simple part, right? It's just recorded existing data. So what's interesting now is we want to predict the future, or we want to predict the unseen things. In this case, the unseen would be the missing values. Let's say if we want to predict the rating that user 6 will give to item 3, so you can look at the question mark there. We want to predict that value. Why we want to predict that value? Because if we can predict that value, we can predict all other missing values. And by predicting all other missing values, we will be able to recommend items to every user. Follow that? Yes?
What's your algorithm? What's the method to predict that value? You just take a median or an average of every user's responses?
Right.
Same item?
The question is what algorithm we use to predict that value. Are you asking in PredictionIO or in general?
Well, I'm thinking you need to take a median and average, but that could be all wrong.
Yes.
You must have used some other way to predict.
If we take the average value, it means that the value of all unseen items. So the question is, if we take an average value, then how can we do the predictions? Something like that. Anyway, so if we use the average value, the problem is that for each user, the average value for each item would be the same. Then how can we rank the item and recommend to the user? So it's not possible. In research area, there are literally hundreds or more methods to predict this kind of missing values. The one that I'm talking about today is called K-nearest neighbor collaborative filtering. Again, come up with a really fancy name, but it just means that taking the items that is similar to the item that you're targeting, and then you try to find the missing value. I can go through it really quickly. So let's say we want to predict the value for predictive rating that user 6 will give to item 3. Because the name is called K-nearest neighbor, what it means is that we want to find K number of items that are similar to item 3. So in this case, we have item 1, 2, 4, 5. And we want to find, let's say, the top 2 most similar items to item 3. What can we do? The simple method, but powerful method, probably used by a lot of e-commerce websites, application right now, is correlation. Again, there are lots of methods about correlations. You can use Pearson correlation, you can use cosine correlations. I know I'm getting people confused right now. Whenever I talk about the method, I would say there are a lot of methods to do that. There are a lot of algorithms to do that. And that's exactly the problem that PredictionIO will solve, that I will talk about later. But for now, let's focus on this method. We want to calculate the correlation between item 3 and every other items. So let's say we want to calculate the correlation between item 1 and item 3. One way to do it is based on previous data. We find all users that have given ratings to both item 1 and 3. in this case, you can see user 1 has rated item 1 free and item 3 free. And user 4 has rated both items as well, user 7 and user 9 as well. So based on this shared rating, you will get a vector R1 and R3, 3514 and 3425. And based on these two vectors, based on common rating of users, you can calculate the correlation, depends on your correlation functions. And we get a conclusion that the correlation score between item 1 and item 3 is 0.8. You don't need to worry too much about the details, how we calculate that, but just remember we're trying to calculate a correlation score with a consistent method for every item pair. And if we do that, we'll realize that item 1 and item 5 are the two most similar items to item 3. And because they are similar, and they have a correlation score, one is 0.8, one is 0.9, we can then use, because now we're trying to predict the preference of user 6, right? So now let's see what is the score user 6 has given to item 1 and item 5. That is 4 and 2, right? So you use 4 times the correlation score plus 2 times the correlation score, which is 0.9, and divided by the sum of 2 correlation score. And you got 2.9, which is the estimated or the predicted score that we have. So now we know user 6 is probably going to give a 2.9 rating to item 3. It is really just one method of doing this kind of prediction. And the goal.
One question I had: does it matter whether how exactly you place sixth user in the 6th place? Does it matter if that 6th user is on the first call?
It doesn't. For this method, it doesn't matter.
Okay.
Yeah, because basically it's just the sum of the correlation. So no matter how you rearrange the sum, it doesn't matter. Sorry. Yes.
So my question is, this preference is based on some algorithms. Here in this case, it's a correlation. The preference may be different if you do a cohort analysis. For example, a different type of Mondays versus Fridays. So how you're adjusting the cohort analysis?
Right. So the question is, besides correlation, for example, we can do cohort analysis, taking just Monday data into consideration and Wednesday data into consideration. Maybe they will have different preferences on Monday and Wednesday. I think it's completely relevant. So the idea really is there are hundreds of ways or more ways to do this kind of prediction. And the goal tonight is not really to get you to become an expert of one algorithm, or not that I'm trying to sell you one algorithm that we invented, which is the greatest in the world. Exactly the opposite. What I'm trying to say here is, for each algorithm, you still have a lot of concerns, like cohort is one. Maybe the threshold, like, do you want to discard the item pairs with really low similarity score or really low correlation? Maybe you want to discard them to improve the accuracy. But how many items do you want to discard? Or what is the lowest score that would become the threshold? Or like the minimum requirement of preferences. Some users, they're inactive users. Maybe they just come to the website, they give a high rating to their own restaurants, and that's it. So we want to discard this kind of users, right? But what do you mean by minimum requirement? Like, how many is a lot? How many is not enough? And maximum number of similarity per items. So I mentioned that it's called K nearest neighbor, right? So what is the K? How many similar items should I take into consideration when I calculate this kind of correlation scores and do a weighted sum? And really, there are a lot of assumptions we're making in this example, and we're not taking cohort into consideration. We're not taking a lot of things into consideration. So my point is, just by using this really simple algorithm, K nearest neighbor algorithm, we're making a lot of assumptions, and there are a lot of hyperparameters we need to tune in order to make an algorithm accurate in your production environment. And that's why a lot of companies, they need to hire, assume you guys are hiring data scientists as well. You need a huge team of data scientists in-house to tune this parameter. And this is perfectly fine. And PredictionIO is not here. And PredictionIO is not here to replace data scientists, but more like we're trying to do the heavy lifting, the boring job, so that data scientists or engineers can focus on more important stuff like feature selections, like choosing the right clean data cleansing and other more important stuff. So we're doing the software engineering heavy lifting at the back. So what we want to do is provide you a framework so that you can evaluate which algorithm you want to use and evaluate the setting of hyperparameters. So again, PredictionIO is, we're not a black box like other solutions. We have the best algorithm. No, it's not like that. But as a framework, we now integrated Mahout, the machine learning library, into PredictionIO. We plan to integrate other machine learning libraries as well. And because it's open source, you can write your own algorithm on top of PredictionIO. And the goal of PredictionIO is to help you to evaluate algorithm and deploy it in a scalable way on production. So when we talk about evaluation, it is important to have evaluation metrics, right? So KNN algorithm, other like ALS, other content-based algorithms, which one is the best for your own application? And what parameter setting is the best for your applications? We need a scientific metrics. There are a number of scientific metrics that you can choose, but honestly, the best one would be the online testing, A/B test. So if you are lucky enough, you have a really high traffic website, you just launch it on your website, and then you can compare the result of multiple algorithms to see which one will get you the best score. But I don't think there are a lot of websites or companies or applications in the world that have so much traffic that can test so many combinations. So at least we need a baseline offline evaluation to do the preliminary filtering. So the evaluation metrics that I want to talk about today is called MAP at K, which is mean average precision at K. So let's take the recommendation case as an example. For this user, A, let's say we want to, in this application, we can recommend 5 items to user A. And actually, user A is interested in 3 items only, 7, 10, and 25. So the total relevant items are really just 3, but we have a chance to recommend 5 items to user A. And you can see that, wow, we got 2 correct. So we got item 10 and item 7 correct. And take notes at the ranking, because in most applications, you can rank the recommendation. Like in a mobile application, you always want to put the most relevant one on top, and then you sort it according to the order. So how good is this prediction, for example? So now let's see how we can calculate the MAP at K. Again, item 10 and item 7 is correct, and they're placed on position 2 and 5 respectively. Which means that the number of relevant items up to this point for item 10 is 1, and for item 7 is 2. And precision at K means, for this K is 5 at this moment, in this example, because we can only recommend 5 items. So the precision at K is 1 divided by 2 for item 10, and 2 over 5 for item 7. And so the average precision at 5 would be calculated by this equation. And then the mean average precision, meaning that we want to calculate the average precision for all users in your test case. And then we will get a score, and then we will get an MAP at 5 score.
How are you calculating KK?
Sorry?
How are you calculating KK?
AP, right?
Yeah, KK. You have one half and then you have 2/3.
Yeah.
Sorry.
Oh,
Here?
Yes.
Yeah.
No, he's talking about the one column. How did you come out?
Yeah, exactly. The
Yeah.
values.
This
No,
one?
next
No,
next
no,
column.
This
he
one?
Yeah,
had-
that-
he had K,
Oh,
yeah.
just 1
Right.
over 2
Yeah,
and
two.
2 over
Fine.
5.
Okay.
Actually, there is even a time element, right? I mean, really, 1 out of 2, or you're basically making a assumption. They are done in a sequence, right?
Yes. So this evaluation is not taking the.
So it's stream based. Basically, as you go, you're modifying the value. It's not because otherwise the first P over K should be 1 over 5 or something like that. You only have 2 values, so it's 1 over 2, and then you're going down.
Oh, the 2 and 5 means the position of item 5 and item 7 in this K. In this K recommendation, K is 5 in this case. So the advantage of this MAP at K method is that we can take the ranking, the order of the ranking into consideration. If the first item is correct, then our score would be higher according to this equation. If the 5th item is correct, it is good, but the score would be lower.
A metric bias towards what you care more about.
Yeah.
But it's not penalizing for the recall. I mean, you just
Yes,
25.
exactly. So it's called mean average position. It's not mean average recall at K. But you're perfectly right.
But because if you get 1 out of 50, and then 1 is the first one, your ranking will be way high, although it's a garbage result.
Great point. So you point out a really important thing is, this is not the only evaluation metrics in the world. There are other evaluation metrics. Some take into account of precision, like this. Some take into account of recall. And there's a method called FP or something. I can't remember the name. But basically, they combine precision and recall score into one and form an F score.
Is just take the FP with the positional data and
Yes. And which evaluation metrics is the best? It depends on your application. Like if I simply want to have the highest prediction accuracy, if I simply want to have the highest number of items that are relevant in my recommendation, then mean average precision is good enough. But if you're taking some competition on Kaggle or other data science competitions, sometimes they want to evaluate the error rate. So in that case, root mean square error would be the metrics that they use. But some research papers show that RMSE is not the best for practical world. But anyway, I'm not trying to advocate MAP at K, but rather I'm just trying to show you one of the evaluation metrics that would work. And so the lesson here is it takes a lot of calculation just to evaluate the performance of the algorithm on one user. And the other lesson is there are a lot of evaluation metrics. And if you, as a data engineer or developer, if you need to implement all these metrics into your application, in your company, it takes you a lot of time. And that's why you need PredictionIO here. So I was trying to show you all the basic concept, how you build a predictive application. But with PredictionIO, you don't need to go through all this pain. What we need to do is, first, you install PredictionIO as a server. It's open source. It's like MySQL. So you install the database server. But in this case, you install PredictionIO server. And then you can download the SDK in whatever language you like, or you can write your own REST API client. And then in this example, we used Python. So you call the Python client, and you include it. And now we want to record user behavior. So in this case, you add a user. Let's say we have 10 users. Then we will call create user 10 times for the 10 users. And let's say we have 5 items. And then how many items? What's my example? Anyway, so let's say we have n items. Then we will call create items to add the item into PredictionIO. And you can add different attributes into it, like the type of the item, because in your application you can have books, you can have restaurants, always thinking about restaurants and food, but anyway, you can have different types of items. And now you can add the behavior into PredictionIO. So user view an item, user rates an item, user purchase an item. You can simply add this data into PredictionIO with one line of code. And now you can get the prediction result, again, with just one line of code. But the interesting thing is you can specify the engine. Engine is the key behind PredictionIO server, which I will talk about really soon. So with PredictionIO, we're here trying to solve production difficulty of machine learning solution. So when you add data into your own machine learning server or your own machine learning solution, most of the time, in our experience, we face the scalability problem. If we have a lot of real-time data that we want to stream into the server, it is challenging. Another bottleneck is the storage, right? If you're trying to record all the user behaviors on your website, the size of this database can grow up really fast, and you need a really scalable solution for that. And not only about storage, but you need to process the data to calculate the really computationally expensive algorithms. For example, the k-nearest neighbor. It takes a lot of calculation to update the predictive models. And so how can you have a scalable data processing framework is really important. And then you need to achieve prediction in real time so that you don't want to have any legacy between your application's call to the machine learning server. So there are a lot of challenges. PredictionIO is a server stack that is built on top of state-of-the-art open source algorithms, open source technologies. So the one product that you guys must be really familiar with would be Hadoop. So right now we rely on Hadoop for data processing at the back. We want to integrate with other data processing systems like Spark or Storm in the future. It is on our roadmap. And for data storage, we have MongoDB, but really PredictionIO is data agnostic, so you can plot it to your own database server if you like. And it is completely open source. So although we only integrate with Mahout right now, but you can add your own algorithm. But I would strongly encourage you, if you're not, if you're just starting to use machine learning for your first time, or if you're just trying to implement machine learning solution in your startup product, I would suggest you to implement something out of the box so that you can get a baseline result recommendation, probably within just an hour or so. And then when you have more resources, you can implement your own algorithm, and then you can use online evaluation or offline evaluation to benchmark which algorithms would be better for your application. So the questions that we're asked frequently is, so what's the difference between PredictionIO and Mahout or GraphLab or other machine learning library?
You're doing the parameter search on top.
Yeah, so we're not only doing parameter search, but the whole idea is that we really like Mahout machine learning library, and we want to put it into production so that developers can use it easier. And parameter setting is one important thing that one important problem that developers are facing, and they need to solve it. And the other one would be, just as the graph that I've shown, is all about the scalability at different setup, like data storage, retrieve prediction, data result filtering. So I would say that we're a layer on top of Mahout. We're not really competing with each other. And in fact, we would really like Mahout to have more sophisticated algorithms so that we can implement it on PredictionIO, and we would love to contribute back to Mahout as well. So this graph is, this screen cap is one, maybe you cannot see it really clearly, but basically it's the user interface of PredictionIO. After you install PredictionIO, it comes with a web interface. You can create engine. you can create multiple engines for your applications, like recommendation, similarity. We're planning to add other engines into it as well. But again, because it's open source, you can add your own engine. Out of the box, it comes with a number of configurations, like freshness or serendipity. Back in the day, without PredictionIO, maybe you need to modify the algorithms, you need to do a lot of stuff to increase the serendipity of your prediction result. But now you just need to move the slide bar, and your prediction result will be changed. So we're talking about algorithms. So this is a list of algorithms that we have included in PredictionIO. Some of them comes from Mahout, and some are algorithms developed by us on Scholar. But you can write algorithms on any programming language as long as it complies with the input and output format. So when you can add multiple algorithms into your engines, and then we'll give you the interface to control the evaluation of algorithms. So at the end, you will see a score like MAP at K-score or RMSE score to see which algorithms and parameter setting is the best for your own application. So it's all on a graphical user interface. We'll also add the command line interface later on, but now it's on the REST API, so it's quite flexible.
So is there some kind of table where you can plan a design of experiments so you can vary K like 3, 9, 27 and vary your distance metric and try the different combinations of those? Okay.
Yes, so we have a built-in report to show that for this algorithm, what is the score, for this parameter setting, what is the score, and you can also set how you want to split your existing data to simulate the testing environment. So it's all built in on the user interface already.
Okay, so does the system generate those parameter searching, or can I input those?
So you can do the manual setting. So you can specify the values for each parameters, and then you can add it for evaluation. But we also come with a function called auto-tuning, which is kind of based on my previous research on hyperparameter optimization. It is really computationally expensive. So the best way to use the auto-tuning is you launch a lot of MapReduce instance, like Hadoop instance on, let's say, Amazon Elastic MapReduce, and then you run through the evaluation, and then you shut down the EMR instance afterwards. Because you only need to evaluate it once. You don't need to run the testing every day. So that's the best way to do the auto-tuning if you want to use it. Thank you.
I had the same question effectively, but now that it's answered, how does somebody do this today without the help of multiple Hadoop servers? Is it more heuristics, or there's some other, like, just because you've done it many times, you know?
Yeah. As far as I know, there's no really good way to find the best algorithm for one particular application, because each application is unique, and the data set, the quality of data is unique, and user behavior in each application is unique. So you really need to find the unique parameters for each application. And that's why I think PredictionIO would come in handy in this kind of situation. And it comes with a default parameter setting, which works quite well generally in most scenarios. But it also depends on the algorithm. Let's say if you're doing support vector machine, I think they have some research about finding the best parameter for support vector machine, particularly for some application. So it is really specific to one area.
So how does this input comes in? Is it a structured data or unstructured?
Right now we provide a REST API, so it's kind of like a structured behavioral data, like to import data to Google Analytics or the log file. So it's like a log, but whenever a user behavior happens, you log it into PredictionIO. You can also import it in batch, but it's kind of structured.
What I meant is it like I take the web logs or armature logs or whatever the logs, and I feed it directly to this PredictionIO? Or is it a real-time streaming? I need to do it to.
Yeah, so that's the real time and the batch mode that I was talking about. We support both. So you can import the data in real time, and we provide asynchronous SDK, so it's not blocking your application. But on the other hand, we also have the batch mode import system for you to import the web log into PredictionIO as well. But we're not doing the automated formatting for you. You need to format it somehow to fit the format of PredictionIO.
Is there a way to combine the applications together and see how that does it versus the single ones together?
Sorry?
Is there a way to combine the algorithms together and see how they do versus the single ones?
So the question is, can we combine multiple algorithms together to enhance the performance, I assume, right? So this is called ensembled learning, or ensembled algorithm, basically. In our infrastructure, we will see it as a unique algorithm. So you need to build a new algorithm, which is called an ensembled algorithm, and you combine multiple algorithms into this single new algorithms. But we don't have built-in ensembled learning algorithm at this moment. Okay, so where are we? Okay, we are at this diagram. Probably the last diagram that I want to show you. It explains the whole server architecture of PredictionIO. On the right, you see that it is your web application or mobile application, and you input data into the whole box is PredictionIO through SDK in Python, Ruby, PHP, Java, whatever, and then it will go through our REST API server, which is built on Play framework. It's a scalable Play framework, and then it will be stored into the app database. And in the app database is MongoDB right now, which is scalable, horizontally scalable. And then through Mongo, we would export the data to HDFS format, and it can be processed by Hadoop. And the result will be stored into the prediction model database. At this stage, we're also using Mongo, but you can separate it to a different Mongo installation. One is for storage, one is for real-time result retrieval. And on top of it, we have a workflow scheduler, which control the work of periodically the work that you need to do on the data processing. So what does the job scheduler means is it actually connected to the admin web UI, so which is the graphical UI that you have seen. You can tune the parameters. You can.
Is it Zookeeper or something else?
It's Quartz right now.
Oh, cool. Okay, that's good.
It was really difficult for us to choose which open source technology to be incorporated into this whole PredictionIO stack. We're just making our best guess at the beginning to get the project started, and we want to make it technology agnostic in the future. But really, if you look at this diagram, you can see how much time we have saved for you as a developer to implement the recommendation or prediction server on your end. So this is architecture of PredictionIO.
One question: is any of those pieces hosted by you, or everything we need to set up on this?
Okay, is it hosted by us, or is something you need to set up yourself? So PredictionIO is hosted on GitHub, completely 100% open source, github.com PredictionIO. But we want to make it really useful, really easy for developers to deploy that. So if you like, you can download the source code, compile it, run it. If you don't like, you can use our binary installer, which will try to set up the whole environment, Hadoop, Mongo, and everything for you through the binary installer. But if you still don't like this option, we support Vagrant, which is a developer box. So they launched a virtual box for you as a testing environment. But if it is still not enough for you, we are listed on AWS Marketplace. So just go to AWS Marketplace, PredictionIO, and then you can launch a whole prediction server instance with just one click, and you need to pay Amazon, not us.
But you're not running a service in the cloud.
based on your software?
No, we're not hosting as a cloud service at this moment. But if you like the cloud model, you can go for AWS Marketplace, which is kind of like cloud with full access, so you can access it. We're a group of engineers, data scientists, developers behind PredictionIO project. We don't really like black box cloud service. They just, I mean, I like cloud service, but I don't like black box machine learning service. One reason, I think it's easy to install, but as my company go forward, or as my application goes forward, I want more control of what's happening behind the scene. I want to have more control of the data machine learning infrastructure that I'm using. So that's why we choose the open source route. I hope it makes sense to most developers here, but we love to hear more feedback.
One question. Can you go back to the previous slide?
Sure.
So during your data processing, is the data get stored in your HDFS, or is it just the streaming of the data in the on the fly it happens?
For the current scenario, because we rely on Hadoop at this moment, so it will be stored in HDFS and then process it, and then it will write back to Mongo through the Mongo Hadoop connector.
What I meant is it going to be persistent in the data in the HDFS? Like after you're done with the processing, you got the result.
Oh, it will be stored back to the prediction model.
Okay, so the data will be erased there.
Yeah. So the question is, whether after the HDFS processing, where will this data be stored? It will be stored in the predictive model database, which support real-time querying. I think it is really important for many applications to have real-time querying, real-time filtering, instead of just storing the prediction result, the score, in text format or HDFS format. Thank you.
Thank you.
How do you get the data in there to start with? You have a large amount of data. You have to somehow just send it over there each time you're going to do something, or you
So the question is, if you have huge amount of data, how are you going to send it into PredictionIO? One way is, of course, through our SDKs. I know you have a lot of data, but if you host the server internally or really close to your applications, I still think it is possible in most cases. But another, I think, better answer for you is because it's open source and the format that how we store the data in Mongo server is open. So we can kind of cheat this way, is that we convert your data into the Mongo format and then we dump it into Mongo directly.
In your PredictionIO model, do you take constraint parameters into consideration? For example, let's say when you recommend top 5 items, let's say each item might be subject to, let's say, certain price or quantity constraint, right. Or this user, let's say, has a budget of $100 and you want to purchase, just up to certain items.
So the question is whether we support constraint, or can I rephrase it as post-filtering? Like after I got a list of recommendation, I want to display only items with certain attributes that I like.
Yeah, but that might, I'm not sure whether filtering, post-filtering would be appropriate, because it might impact user behavior or preferences.
Yeah, so the question is a little bit more complicated than I just explained. Because, so for the data, sometimes you have some attributes that you want to take into consideration. You don't want to use, let's say you just want to use data of class A for the prediction. You don't want to use data of class B for the prediction. So in PredictionIO, for pre-processing, we actually support multiple engines. And in each engine, you can define what data it will take into consideration when it builds a predictive model. So that's one way to handle it. Another way to handle it is after the predictive model has been built, when you retrieve the prediction in real time, we also support a filtering function, so you can select certain data only when you return the prediction. So that's a pre-filtering or post-filtering approach that you can select. But I know there's some applications that are more specific. We might need to fine-tune the algorithms for the input and this. But I'm happy to learn more about your use case so that I will see if we can improve the product for that. So let me know after. Yeah.
So what's the business model? Is it open source or open source plus consulting?
Business model, we look up to MySQL, MongoDB, so we want to be an open source company. Eventually, I think we will need to, actually some enterprise companies, they are interested in some enterprise support, but we don't have the resources to do that at this stage. So for now, our focus is really to make it useful. Because as you can see, there are a lot of use cases that not a generic product can solve easily, but we're trying hard to do that. So I think we need to focus on the usability, usefulness of the product at this stage.
The drawing over there, I see both mobile and web apps, so it looks like it's like a real-time setup. Can you talk a little bit about numbers, like what sort of round tripping you get out of it?
So the round tripping, I don't have a specific number at this moment, but we rely on Play server, Play frameworks, REST API support. So
it's something that can be used in real time. I mean,
yeah, we see some use case like million transactions per day, and it is fine. So because it's completely scalable, so it depends how many servers you want to use for taking the data. So the benefits of this architecture is that it is scalable at different parts, like data storage, data processing, real-time retrieval. They're all horizontally scalable. So theoretically, the more server you add, you can handle unlimited number of data. But of course, we need to improve the technology to make it more efficient going on the way. Thank you.
A lot of the algorithms in Hadoop use very specialized data structures, like different kinds of sparse vectors and so forth. Is that all hidden from users of PredictionIO, or?
No. So the question is, do we hide the Hadoop library? They find a lot of, I would say, settings for different algorithms for different scenarios, right? Are we hiding all these settings? The answer is no, because we provide the user interface for you to change the value. And as mentioned, it's actually one of our strengths to help you to find the best value or best parameter for each algorithm for your application.
Actually, in some cases, for different kinds of measures, some of them don't really work with some of the algorithms.
Right.
But you're free to plug them in anyway in Hadoop.
We have a specific algorithm setting page for each algorithm. So you're not like mixing the setting for different algorithms. Take a look at the product. You must not have seen our product. Download it, install it, try it.
Do you support other things besides prediction and say canopy clustering that's in Hadoop or k-nearest neighbors?
So can we do clustering? Can we do trend prediction? Can we do other stuff? No, we focus on recommendation, user preference prediction, personalization, discovery at this moment. It's challenging enough for us, the small team. It's an early stage project. So we stay focused on one particular problem, make it work for us. And feedback is really important.
Who is using it right now, and what are they using it for?
So we see a lot of companies using it because it's open source, so everyone can download it. We don't have any paid customers at this moment, so we don't really know exactly if they're using it on production. But from our Google group, you can see a lot of different use cases. Application store, game application store like Play.io, enterprise like Hadoop, the content management company. We see Fox News, Channel 4 forking our GitHub project, so maybe they're using it.
Cool.
But they do ask questions on Google Group, so I think there's some kind of usage there.
Do you have any benchmarks compared to sklearn, Python SK and scikit-learn?
No, I'll leave. So the question is there any benchmark to scikit-learn or other libraries? I'll leave this job to my house to do this because we're not inventing the algorithms. We're just a framework to implement their algorithms. So whether Mahal is better than other algorithm libraries, I don't know and I don't really care because we want to be a framework that incorporate other machine learning algorithm as well. And it's up to developers to choose which one they want to implement.
Okay, but I mean, in general, how much parallelism are you saying you can get?
Depends on the applications. So
can you repeat the question?
So the question is there any number, like the margin of performance improvement after we make prediction? I cannot really I don't know how to answer that because it really is case specific. Like if you're an e-commerce website, you might see like certain % of increase, but for some other cases, maybe it's not helpful to you at all. So I don't really know. It's kind of case specific.
Okay, but I mean, taking the recommender example, so you said micro-parameter selection. So how much parallelism can you get?
Right.
Can you get arbitrary? Does it top out 16 nodes, 32 nodes, 1,000 nodes?
Right. So I can only give you a really general answer. Like if you look at some research paper evaluating the performance of recommendation on e-commerce website, like Netflix, they can see like 30% profit improvement. It is reasonable, and they're using a similar algorithms that we have in PredictionIO in Hadoop.
How scalable is your data in PredictionIO?
How scalable is data in and PredictionIO? It's as scalable as Play Framework. It's as scalable as Play Framework. Play Framework is a Java and Scala framework, especially designed for high performance input and output. So,
do you have any benchmark number?
No, we haven't done the benchmark, but we can check it out with Play Framework type thing. Any other questions?
Are you going to do any formal documentation?
The question is, are we going to do any formal documentation?
Or are you seeking volunteers to help?
we have a documentation site which is not good because it was done by me. I'm trying to put up as much content as possible on the .prediction.io. I wouldn't call it official, but yeah, if you have any specific needs in terms of documentation or the product features, let us know. Like what kind of format would you consider official so that it might be useful for your companies? Let me know, and then we'll try to do it, or we'll try to find people to help us to do it. And we really need contributors at this stage. Thank you.